Hi, and welcome to our Spotlight in Science Cole-Parmer webinar. Thank you, wherever you are on the planet today, for joining us. I'm Joe, I'm your host. I'm here with some very special guests, but before I introduce those, I just need to talk you through the system. So if you're watching this from a laptop or from your mobile phone, everything on the screen right now is movable and resizable, so you can make it fit your viewing screen to make sure you can watch this properly. If you've got any questions, there is a Q&A box just to the left of the main screen. Just type your questions in. All questions that we receive are anonymous, so ask whatever you like, whenever you like, and we will read them out at the end. There is also an on-demand version of this webinar, so literally about an hour after this webinar ends, an email will be sent out to you with a link, so you can watch this on demand, or you can share it to people that haven't watched it yet or couldn't make it today. And also, you'll notice there's a little floating purple box. If you click on that at any time during the webinar, it will contact the team here at Cole-Parmer, and then we'll get back in touch with you. So if you're interested in getting more information on how to start up your own lab, just click on that purple box, and we'll get right back to you. Okay, that's the introduction finished, and now, as you can see on the screen, we've got Valentina and Christian, and we've also got Jane. So, Valentina, would you like just to introduce yourself to us?
Yeah. Hi, everyone. Thank you so much for joining. I'm Valentina Gomez. I'm one of the co-founders and the COO at Werewool.
And my name is
Christian.
Oh, sorry, I jumped the gun. My name is Christian Joseph. I'm a research scientist here on the materials and fiber team at Werewool.
Fantastic, thank you. Jane, would you like to say hello?
Yeah, sure. So I'm Jane Bates. I'm sort of a technical support manager in Stone in the UK. So I support the products that we manufacture for Cole-Parmer.
Brilliant. Well, thank you all for joining me today. What will hopefully be a really good and interesting webinar for everybody. So I'm going to start off with a few questions for you, Valentina and Christian. Do you mind just telling us a little bit about yourself and letting everyone understand what Werewool's all about and what you do?
Yeah, so at Werewool, we're developing a new type of textile fiber that looks to recombinant proteins for color and function. And we started off back in 2018, our research started. My co-founder, Chu, and I, we were students at the Fashion Institute of Technology. We were studying textile development. And when we were in school and during our work experiences, we just really started to learn about the impact of the fashion industry. And a lot of that impact came from the fibers that were being sourced. And so we decided to do something different and create a new type of textile fiber that wasn't reliant on the traditional plastics, the dyes, and the finishes that are used in the industry.
Yeah, so did you get to study like the traditional way that fibers are sourced? So like you just mentioned the plastics and everything. Did you get to research all of that as well?
Yeah, so our studies were mostly focused on the development of fabrics themselves. So mostly of like the weaving, the knitting, the dyeing process. Yeah, and then also looking at like what fibers should be sourced for an end product.
And actually, just out of interest, so in that sort of what fibers should be sourced, was that like the traditional sense of what
Yeah.
most of the people do? Yeah.
Oh yeah, so it's like the cotton, the polyesters, the acrylics. Yeah, not really looking at the new type of textile fibers, mostly the traditional ones that are used.
Got it. So that's once you'd finished studying all that, that's where you got the inspiration to try and make a difference with
Yeah.
what you're doing.
Yeah.
Yeah. So what is it you actually want to achieve? What is it? What's your end goal here with Werewool?
Yeah, I mean, our company mission is to make the fashion industry compatible with nature. So we're really trying to reduce the reliance on those plastics and the toxic chemicals and the large water usage that is used as well. That's our main goal.
Got it. I mean, that's a brilliant mission.
Thank you.
And you know the name Werewool, that's quite an interesting name. So I was kind of wondering, I'm sure everyone here is wondering why is it called Werewool?
Yeah, so Werewool's inception story name. When we started off, we joined the Biodesign Challenge, and so that program it gets non-traditional science students to think about what your industry could be if you look to biology and biotech. And that year there was an animal-free wool challenge, and so we tried, did not succeed, to create a wool alternative that was created by the saliva that's found in our body. So hence the name Werewool. That's not what we're doing today. We're now trying to create a different sort of textile fiber that's not really an alternative to wool. But we just kept the name because it's close to our hearts.
Yeah. See, yeah, I guess when you're in the early stages of starting something really exciting and you get the name, I suppose you're sort of a little bit bonded to it. You kind of have an emotional connection to that beginning.
Yeah, I mean, for us, when we release our first fiber into the market, the name will, the name of the fiber will have a different name, but the name of the company it remains to be Werewool.
So
Yeah.
do the fibers have any resemblance to wool in any way? I know there's sort of like protein fibers and wool is proteins. Is there any connection between the two?
No, just
No.
it's a protein-based fiber, but it doesn't feel like wool. I think Christian can go into it more because he works on that side.
I think, you know, when talking about what the fiber is comparable to, we look at some key properties of the fiber. And typically, these are mechanical properties. And these are a little bit more translatable into the hand feel and how they perform in comparison to other types of fibers. And given that the fiber is still undergoing development, I wouldn't necessarily make any product claims about how it's similar to a particular industry standard fiber out there. Yeah.
Okay, so they have sort of unique properties then.
Yes.
Yeah.
Yes.
Yeah. Cool.
Yeah, that is really interesting. Because I was kind of, as you were saying that, I was kind of visualizing what the finished product might look like. Is it when you say that when we're talking about fibers and wool, are we actually talking about, you know, like I would know it as like woolly jumpers or woolly hats or that, you know, is it going to look like that, or are you actually expanding into all sorts of different types of fit and kind of style of weaving and etc. Is what you guys can do quite broad, or is it quite narrow in terms of, you know, the actual fashion items that you could contribute fibers to?
Well, I think right, the goal of the science behind everything is to create a platform that allows for the incorporation of recombinant proteins that can impart particular function. So the recombinant proteins that you use, one, for example, color is really important to us right now. So the recombinant protein that we're using is in the material system in order to have color. But the goal is that, or the hope is that the platform can be used to impart other things that are inspired by nature into the material. So, and this can extend into mechanical properties like stretch or certain, certain types of performance. So yeah, and that just means like different products would be made, right, off the basis of a platform that ultimately aims to use nature-inspired recombinant proteins.
Okay, so like your jacket, for example.
Yeah.
Yeah.
I wouldn't say it's tied
That's awesome.
to sort of product. So
Yeah.
Right.
No, I love that. I think platform's a really good word, actually. That really helps sort of focus the attention on what it is you can do. So you can sort of, it's almost you're saying there's a lot of things that could be done, It's not just
Right.
one single thing. Yeah. No, that's brilliant. So one question I know that a lot of people here today would really want to know about is like the process you went through to get started. So it's clear you had an inspiration, which is brilliant. This kind of the environmental side of it is awesome. But you've developed a business, and you've got, you're sharing a lab where you are, and you've done so many things. So could you just talk us through like how you actually got started? To where you are now.
Yeah, so we started off in college, how I said earlier. We had an amazing mentor that took us under his wing and let us work in his lab. But it really clicked for us one day when he showed us this like vial that was beautiful, like red fluorescent pink color. And we were like wondering what sort of dye that was, because that's naturally where our brains went, because that's what we knew. And he was like, no, this is all protein based, it's structural color. And that when we were like, wow, can we create fibers from these beautiful pink colors? And that's where we started our research. We tried making fibers out of that red fluorescent protein. And we worked in his lab for about a year. And then we had our professor, Thean Chiros, who's now our CSO. She had an appointment at Columbia University. So she connected us there with biomedical engineering labs and chemical engineering labs. And we worked there for about 2 years. We got a grant through the NSF. And then we really ramped things up in 2020 when we got a grant from the H&M Foundation. And that was when we moved out of Columbia, started working in our own lab. Yeah, that was what kicked us off, was getting that grant from H&M. And then last year we closed our seed round as well and started to grow the team.
Okay. Okay, so that bit I'm not sure about. You may have to explain that to me in a sec. But you said NSF earlier. What
Sorry, that's the National Science Foundation. It's part of the government in the U.S.
Okay, so you would literally pitch your ideas to them, and they'd say, "Oh, that sounds good. We'll give you some money." Is that how it works?
Yeah, for the first like 2.5 years, we just relied on grants for funding. So a lot of like pitch competitions, writing grants for different organizations. We got a grant through the Biomimicry Institute as well. Yeah, that was our like main source of funding for the first 2.5 years for us.
And then H&M, the big fashion house, H&M, the retail, the high street.
Yeah, so they have a foundation that is separate from the brand that they do a grant every year where they give over $1 million, split across 5 different companies.
Right.
Yeah.
And you're one of those companies.
Yeah, we were really lucky to get one of those. We couldn't believe it. We were picked.
That's awesome. I mean, I love H&M. I think it's a brilliant brand. So actually, can I just ask you a question? Does that link you then? Does the work you're doing on your platform, does that link you directly back to H&M? Do they have like an interest in your company, as in what can you do for us on our retail side, manufacturing fashion? Do you have a direct feedback loop to them now?
Yeah, we definitely rely on them for feedback, and we're in conversations, but there's not anything like official by contract or anything like that. But they've been an amazing resource for us, with connecting us to manufacturers and just getting to talk to their development teams as well.
So if H&M launched a line of outfits that were, say, using some of your technology, some of your platform, do you think they'd say like designed by Werewool, or not designed but made, would your name, do you think, appear in the labels somewhere if they were to do that?
I think that depends on the partnership that we put together. But we do see like Zara did a collection with Cirque, who is a textile recycling company, and they got their name on the label. I think it just depends on the partnership that you get.
Got it. Something to aspire to, maybe. If that ever happens, let me know, because I'll be out there buying Werewool stuff.
Yeah. It'd be the happiest day of my life.
Mm-mm. Yeah, that'd be awesome. I feel that. So basically, all your funding's come from grants, and then you got this lucky break with the H&M Foundation, and that's kind of springboarded you to where you are now. That's allowed you to buy the equipment and invest in lab space and that sort of thing.
No, what? So that was a big part of it. And then last year in March, we got our seed fundraising round closed with 2 investors, and that's what really allowed us
Oh,
to
right.
build out the lab.
That's the bit you said earlier. Yeah. Got it. So 2 more investors came into you.
Yeah.
Oh, that's awesome. Was that quite stressful?
Yeah, I would say fundraising stressful, but you learn a lot from it, and I think you learn a lot about like planning for growth as well. So it's definitely a good process to go through, and it's necessary in order to grow the company. And so next year in February, we'll start raising our next round as well.
Oh, so you got to do all this again next year?
Yeah. And then after, yeah.
So you got to keep going. Wow. Okay. And I guess, does it stop once you've? I don't know. When do you stop doing that? What's the end point?
I mean, our end point is really to get products out into the market and start making a revenue as well from our partnerships as well. So.
Okay, and then when you're making the revenue, then that's when you don't need to go to the funding groups and do it because you already got revenue coming in and things like that. Yeah.
I think you still have to go to the funding groups because you're always trying to grow.
Right.
I don't know if it ever ends, really.
Okay, so I've made a note of growth plan. That's something that I think other people might need to take note of if they're getting involved. So in terms of going back to how you guys, produce or make or operate as a whole, is there anything? I know, Kristen, you alluded to some the platform earlier, and you and Jane had an interesting conversation. Is there anything in there that you haven't already expressed yourself that perhaps talks to some of the processes you use in the lab or some of the principles that you apply, or any particular sort of technologies that you haven't described yet that you're using?
Yeah, for sure. So when it comes to fiber production, there's various methods of making fibers. Because of the nature of the platform and the things we want to incorporate in our material, we use a process called wet spinning. Wet spinning is used in materials like viscose rayon to produce fibers, and so we use it as well. And so basically, what wet spinning is that you have a polymer dope solution. This contains the basically ingredients of your material, and it's dissolved in some sort of solution that can then be pushed through a die. And that die has a bunch of little holes in it, and each of those little holes makes a fiber. And so that polymer solution goes through what is called a coagulation bath or a non-solvent bath. And basically, the point of that is to take that solid material that was in solution and bring it back out of solution and to solidify it. And then that gets thrown down a series of steps afterwards to process it. There's drawing that helps set a microstructure and impart mechanical properties. There's washing to remove some of that coagulating fluid I talked about earlier. There's drying to remove solvent as well to get it more to get a dried product. And there's also different finishes that we use, or some call it sizing, to control friction between the fibers and the equipment. So there's a series, and so that's just producing the fiber itself. Getting that into a yarn and then a textile as a whole another side, which I would say like in-house is not the biggest focus right now. But yeah, uh, I would say, I think what's really, for the materials and fiber team, what the really big thing for us is this wet fiber spinning process.
So how do you sort of harvest the fibers and handle them once they're produced? Is there like a sort of spinning or weaving process that you would do with like normal fibers that you get?
Yeah, no, this is a good. So I guess what you're asking generally is like how we're collecting these fibers once they go through the process. Um,
Yeah.
so so this is highly dependent on on the where your material's at in terms of strength and how robust it is. So you can collect it, you can let it, you know, pile up at the end of the line. You can just collect it in a pile in a large bucket. Some people wind it onto a bobbin directly in line. Um, but typically, what you want to do is eventually get it on a bobbin because, as I said before, this is just the upstream part of the process of getting to a final textile. And when you want to pass it off to, say, a yarn maker, you're going to want to present it in, um, they call it a package, which is also it's a convenient way to describe it. But you want to get it on a package so you can hand it off to the next guy and he can do what he needs to do to it.
Okay.
So yeah, how it comes directly off the line is can be there's a lot of things to be adjusted with wet spinning. What I described is a general schematic, but I think depending on your material, there are things to tweak and there are ways to maybe do some steps as a separate part of the process. But eventually, the goal is to get it wound onto a package or a bobbin, which is a cylindrical object. Um,
Okay.
that just is like a spool. Like if you ever bought thread in from a sewing shop, it kind of looks like that.
Do they have any specific properties and advantages over the products that you can get nowadays already?
Right. So the property, I would say like the interesting thing about us is the potential platform we're building out, and I would say even with one of the goals is to produce color like via this platform, right? Um, Valentina talked about fluorescent proteins. To achieve that in other um, more traditional textiles or in the traditional dyeing process, those are very unsustainable processes. So one of the, so with regards to color, one of the claims to be made is the claim to sustainability over the competition. And so therefore, we can say that in the building in using the platform for that particular uh, desired product property. But say if we want to use the platform, say if we want to use the platform to build out impart certain mechanical properties, then potentially, uh, you know, we may be we may have performance. We may be able to make certain performance claims. But again, right, what we're talking about right now and where we're at right now is really building out and developing this platform for the potential to make a variety of claims over what currently exists in the market.
Yeah, I would say like for right now, our first prototype is focused on color. So we're able to cut out all that water usage, cut out one of the processing steps. So that saves on shipment costs, lead times, and then the sustainability angle that Christian mentioned as well. So we're not using those traditional dyes that are used, or like on fibers like cotton or hemp or linen, that are biodegradable fiber. Traditionally, when those fibers go through the dyeing stage, a lot of the times it renders it to not be biodegradable. And even if it does, when it goes back into the environment, it can leach those toxic dyes back into our soil and water systems. So we're able to cut out that process completely.
Okay, that's great. And I guess the colors never fade either.
We are pretty color fast. We are working on that, definitely.
Oh, okay.
Yeah.
Yeah, I've got way too many color faded clothes, so I hope you figure that one out, Valentina.
Yeah. We're working on it.
That sounds really good. Just while you were talking there, I just thought, so when you get to the winding it on the bobbin stage,
Right.
can this be localized into the manufacturing plants itself? So I wasn't quite sure because I'm not the expert in this, but whether you're thinking the wool is wound on a bobbin and then shipped out in large stocks to the clothing manufacturers, or whether actually your tech is put into their process. So when they're making the clothes, it's actually the wool spinning is happening in their plant rather than you shipping stuff around.
Yeah, so that's definitely like there are vertical mills that do everything in-house, where from the spinning to the weaving, knitting, and to the fabrication of the garments themselves. I think something about us is that why we've developed our technology to be a plug-and-play solution is that we don't necessarily want to become the manufacturers of these fibers. We're more looking to prove out the technology, but then really our end goal is to license out to manufacturers that already have this system built out, which allows us to scale easier than having to build our own special line. Yeah. If you want to add it.
Okay. Yeah, that makes sense. Yeah, thanks for clarifying that. All right, so you use a lot of equipment in the lab.
Yeah.
Absolutely.
A lot of Cole-Parmer equipment too.
Yeah. So, so it's probably worth just sort of giving us a few highlights. I mean, obviously, we know that you're using some of our equipment, so I mean, feel free to talk about that as well. But there's obviously other bits of kit in the lab as well. Is there anything in particular that is sort of really making a significant difference to you? So I understand the process that Christian's explained, but like there's some of the equipment in there as well that might be worthy of other people understanding a little bit.
Yeah, well, I can speak to the materials side, and then I think, Val, if you want to talk about some of the things that the bio team uses. But on the material side, the big things for us are like, an overhead mixer, being able to mix things into solution, being able to measure things like viscosity with a viscometer. Of course, plenty of beakers, plenty of glassware, need all of that to measure things out. Scales, hot plates, stir plates, develop this polymer solution I was talking about earlier, and make sure that it's fit to go through all the processing equipment in-house.
And then on the bio side, we use a lot is our incubator shakers. So we're really lucky that Cole-Parmer gifted us one, and that's upped our capacity significantly. Also, just use standard purification methods. I think just a general like cloning equipment, we use that as well. I think and centrifuges. We also use plate readers. It's a standard bio and chem space, I would say. We also just got an autoclave from Cole-Parmer as well, so it's exciting.
Yeah.
Okay. Does it help that you can get all your equipment from one place like Cole-Parmer? Does it make it easier when you're searching around that we can offer quite a lot of different things for you to help with your lab processes?
Yeah, I think our account person that we work with, Amy, has been incredible. I think whenever we have something that we need, I've been able to just email her and she's able to send us either what you guys have in stock or what someone might have in stock that could help us. Also, we've gotten some amazing discounts as well, because as you guys probably know, the equipment's really expensive. Glassware is really expensive. And I think as a startup, we're always looking to cut down on costs. So it's been a great resource for us to have.
Yeah, there is a very proactive new startup lab offer and service that Cole-Parmer provides. So,
Yeah.
obviously, labs like yourself will benefit because we're there. We love the science. We support the scientific community as best we can. And a lot of the time, it's simply getting you the right kit, because people like Jane are also very experienced people in the team here who would help specify or work with scientists like yourselves to get the right kit in, and obviously make you aware of the broad range of things that we do around equipment and consumables. So it's really good. I'm so pleased that I got to meet you in person, and we've seen the lab, and it's just a brilliant project that you guys have got going. But you got some plans, you said, about expanding, so you're looking to get more people in?
Yeah, so we actually just hired someone that started yesterday on the bio side, which is really exciting. We have 2 positions open as well right now for a director position, also a polymer chemist. And then in the next year, we're looking to bring in a couple research assistants, as well as another protein engineer and hopefully a textile engineer as well. That's in the next year, yeah.
That's excellent. So maybe we can come revisit you guys in a year or so and just see how you're getting on.
Yeah, I think you guys have came twice now, and it's always really fun when you're here. So thank you.
Well, thank you for being kind. Jane, have you got any final questions you wish to ask?
No, I guess, from now on, you're going to be scaling up, I guess, to start producing more of these fibers that you can take to market.
Yeah.
Yes.
That's the next steps. We're hoping to have some swatches to show in the next couple months and improve the mechanical properties as well. Christian has a lot on his plate right now.
Exciting. Yeah.
Yeah.
Okay, that's excellent. Well, thank you so much for your time today. And thank you, Jane, for joining us and asking those amazing questions. We've hit time, so what I'm going to do is, if it's okay with everyone here, I'm going to collate all the questions that we've received, and then what I'll do is I will get everyone here to answer those questions in Word document, in Word format, and then we'll just circulate the Q&A sheet to everyone who registered. Apologies we didn't do any Q&A, we have hit time, so thank you once again, Valentina, Christian, Jane. Thank you everyone here watching today, and stay safe, and we look forward to seeing you on our next Spotlight on Science. So thank you so much.
Thank you so much. Thanks for having us. Nice to see you again, Joe. Nice to meet you, Jane.
Thank you.
Thank you.
Bye.
Bye.